Hello everyone, welcome back to my channel, Black Box Engineering. I'm making progress on circuit building video. I'm just kind of doing it in a lot of little parts right now. I'm using my iPhone to record things. I do have a camera technically, but the zoom doesn't go far enough, and the iPhone actually has a pretty decent zoom on it. Just want to make sure that everything is pretty easy to look at and view, so it's going to take me a while to compile all the footage together. I got to figure out a way to get my videos off of my iPhone. I'll probably just get like a little flash drive that can plug into my phone, because what I've been doing is uploading to Google Drive, and that's not a very efficient way of doing it. So yeah, just making headway on that. So in the meantime, I kind of want to talk about something else that kind of confused me in class. Again, there's a lot of different things that were, I guess, obvious to me now, but this is another one of those things that didn't quite connect the dots in my head, and it seemed like a lot of the other students too didn't quite grasp this in college either when it came to circuits and circuit design and lab stuff. So the idea, it's kind of hard to go from like theoretical like paper or like schematic to some real world application. In my personal experience, I don't know if this is all classes, but we didn't talk a whole lot about part selection, and I wish that we had. And this kind of has to do with it. So whenever we were shown like voltage symbols or whatever, the only context that we were ever given for power supply that we, so whenever we were told power supply and go to the lab, we would always see these kinds of things. So this is digikey.com. So I'm sure you remember these kinds of devices. The voltage and current is adjustable. Typically, this one in particular goes from 0 to 30 volts DC on the voltage side, and it goes from 0 to 5 on the AC side. So, I mean, obviously, there's a lot bigger ones than this. But anyway, we would only see these kinds of supplies for like lab work, and I think part of the problem is like nothing was explained that there's more supplies than this kind of thing. So we were kind of under the assumption that this is all that existed, and that this current knob, this was never explained that this was not telling the machine to output that particular. Okay, so I just had to learn something myself. I guess I guess we were never told that the current knob was not telling the machine to output that specific current, because that's not how devices work. This is just an outcome of the way that we're taught. So what the current knob does is it sets a sort of threshold for when it switches to the constant current mode, the C.C. So let's say if you set the current knob at 1 amp, and you had resistors that connected to the voltage supply at whatever you set the voltage to, it would draw whatever it needs to. And then if you went lower and lower in resistance up to the current limit, it would do just fine. But as soon as your resistance drops too low and the current increases beyond 2 amps, the machine basically kicks in a safeguard and forces to regulate at 1 amp regardless of what's connected, so that it doesn't burn out the supply and it doesn't cause let's say that load couldn't handle the wattage either, and it would also make sure that the load didn't burn up either. So I actually didn't know this. I thought that it was a knob, and again, this is just, I should have made that connection because I made the realization about power supplies later on too. I just assumed that it was a knob that made it output that current regardless of what was connected. That's not how it works. So, but yeah, none of that was explained to us. So the thing is, when we design a system, I was under the assumption, and I think a lot of other students were too, is, well, how do you select parts when we don't know how much current is going to be required from the supply? And because we were basing our assumption on that supplies must output that current level, we basically limited ourselves in saying, well, a 5-volt supply at 1 amp must always output 1 amp regardless of what's connected. How do you power anything that's beneath that? And man, it sure helps to know that that's not how power supplies work at all. So let me just show you a couple of different power supplies on my other screen, and keep in note that I am not sponsoring these companies at all. I just found random supplies and took pictures of them because I think it's cool to kind of teach this stuff. So just please note that I have no particular favoritism for any of these companies. So anyway, so this is a basic power supply, 12 watt USB power adapter made by Apple. And as you can see from the specifications on the bottom, input is anywhere from 100 to 240. That's a typical house output voltage from your wall. The reason that voltage can vary that much has to do with a bunch of complicated generation stuff down the line. 240 is the absolute maximum a house can output. I think, yeah, I would technically call it 220, but 240 is probably the RMS value, the root mean square, and the supply draws 0.5 amps. So the 12 watt, let me actually calculate that. I'm curious. 240 times 0.5. Okay, so it's not based off the 240 at all. Let's try the 100. $50 watt. Is that 0.5? Yeah. Right, because it's AC. So 12 watts is the output power, not the input power. Input power is going to be higher than the output power. So maximum, the supply would draw 240 times 0.5, which is, it would draw 120 watts maximum based off of the 240 volt. But because it's this number right here is the output wattage, because if you take 5.2 times 2.4, you'll get 12 basically. Let me just verify that here. 2.4, 12.48, so 12.5 watts technically, but yeah, as you can actually kind of see it right here, 12.5, but the nameplate is 12 because it's just easier to say it's 12. Anyway, so what this means is, so this system is regulated to output 5.2 volts, an exact amount. It's probably within extremely low tolerance. That 5.2 is probably going to be pretty exact, and it can output a maximum of 2.4 amps. So that means that, realistically speaking, because of how power supplies are typically designed, they don't really use transformers anymore in modern supplies. You can technically go from 2.4 practically down to 0 amps if you really wanted to. And boy, was that a limitation when I started going beyond college. I didn't understand that this was a maximum rating for the longest time. It's crazy. Let's just go through another example here. So this is a power supply, a USB power output power supply made by ONN. The input is 120 to 240, just like we saw in the other one, but this time it only draws 0.3 amps. So realistically, absolute maximum wattage consumed is 240 times 0.3. That's 72 watts. And the output is going to be 5 volts regulated, maximum of 2 amps, so that would be 10 watt supply. So yeah, again, that's typically, you're gonna pretty much be limited to the 2 amp maximum. Probably realistically, you could maybe potentially get away with 1% above, maybe. Power supplies are pretty sensitive though, especially switch mode power supplies. That's typically what these end up being, because switch mode power supplies are a lot more efficient than transformer linear supplies. But even 2.1 amps might be too much. It depends on the internals, but basically if the connected circuit or system or whatever you want to call it, if it draws pretty much anything over that, the power supply will burn out almost instantly. Again, it depends on how much over you're going. I would probably assume that, I'd say half an amp would probably instantly burn it out. Maybe an amp more. It kind of depends. I don't know the internals of it, but anything above, even if you were to go like just a bit out, it would burn it out, but maybe not instantly. It might actually burn it out over time. Again, it totally depends on the internal mechanism. And then here's another example, and I just learned about this today. So this is a USB-C power supply made by Apple. This is for the modern USB-C phones and iPads and stuff. And so this one's a little bit different. So this one, it takes your 100 to 240 volt AC at half an amp, and it converts it to either 5 volts at 3 amps or 9 volts at 2.22 amps. And the kind of similar thing happens with like a Switch, Nintendo Switch supply. So I learned that these kinds of USB-C chargers have a little bit of a smart controller inside of them, and so the charging block communicates with the connected device, and it can detect whether or not the connected device asks for the simple 5 watt power, or if it's going to ask for the more beefy 9 volt power. I would probably assume that the 9 volt is for iPads. I'm pretty sure that's the case. I'm not sure if iPads run off of the 9 volt or 5. I'd have to look it up. It maybe Airs, maybe the more powerful iPads. Let me just Google this really quick because I actually don't know the answer. Let's see. Apple USB-C. That's the wrong question to ask. When will a Apple charger switch to 9-volt output? Wow, some iPhones use the 9-volt. Oh, for faster charging, that makes sense. I didn't even know that. So maybe it's just adaptable for things that do run off of the 5-volt, like headphones or something. Typically that makes sense now because that the Switch, the Nintendo Switch one here, its default is 5-volt. And I believe I think I did research on this earlier. I believe that the Switch goes off of 5 volts when it's not in docked mode, and then it switches to the 15 volts when it is docked. Correct me if I'm wrong. But yeah, I'm actually surprised that modern phones use the 9-volt 2.2 amp output. I thought that it might be lower. Boy, technology has changed. That's for sure. But anyway, so back to the point. There's a bit of like smart, probably like a microprocessor or something in there that communicates between the device that you are connecting to, and it can detect whether the device requires simple 5-volt or if it requires a little bit more for faster charging. In this case, the iPhones communicate with the charging block and say, "Hey, I want 9 volts instead of 5, higher current." But I'm sorry, higher voltage, because current will decrease with higher voltage. That's how it always ends up being. So if I actually, this is going to be the same wattage either way. Technically 3 amps is 15 watt, but 9 times 2.22 is 19.98 watts. So 20. They're just rounding up. So technically, it just seems the practice that these chargers are giving the absolute maximum wattage output. And technically, I guess you could say that 15 watts is practically 20, but I wouldn't go that far. I'd say that it's reflecting the 9-volt specification rather than the 5-volt. So yeah, 5-volt, the 5-volt will get you more amps maximum. It's just how V equals IR works out. So yeah, USB-C chargers are a little bit more unique, but it still works off the same principle. Technically, you could not get the higher voltage without special like processor. Couldn't just connect like in this instance, you could not connect something that ran off of 9 volts because the charger would not know that it's asking for 9 volts. It would try to do the 5 volt and it would not power a 9-volt thing. So I don't think it would. I mean, I don't know if it is smart enough. It could be smart enough. I mean, Apple's really good at designing things, and it's possible that these kinds of devices may be smart enough to figure out, hey, this is asking for more power. Let's switch over to the higher voltage. Maybe, I don't know. Probably not, but that's a good question to probably look into. But anyway, so yeah, power supplies like these are literally telling you the maximum ratings and the maximum amount of current that it can supply, not that it will output. And that is just one of the things that I wish were explained, because I mean, because we assumed it worked that way, the minute that we learned that there were more supplies than the benchtop supplies, and that's a whole nother thing. We assumed that we had to find an exact power supply that would work at the expected amps that our little setups would work at. So, in other words, like let's say, well, how am I going to build a circuit that exactly equals the 1 amp requirement, or whatever the current output was for the supplies? And that wrong assumption led to really badly laid out designs where we would have to plug in multiple different power supplies because we didn't realize that one power supply could basically run everything as long as it has enough current output maximum. I just wish we knew that ahead of time. Yeah, another one of those things where you learn about it later and you're like, oh, that makes so much more sense, and how I could have designed way more efficiently by getting the parts to you spec out the parts based off of the current maximum so that you, whatever let's say resistors, other integrated circuits, whatever their power supplies require, you just add them up, and as long as it doesn't exceed, you're good. That's how you design things with power. And yeah, looking back on it, I feel silly that I even assumed that it was a constant output. I don't think it's necessarily stupid, because when something like says 2 amps or whatever, I don't think it's a bad like assumption at the beginning to say, well, that must be what it's supposed to output. Because like what other things in real life like tell you that it's going to be this outcome in an exact way? Let me think of an example here. I guess like shopping always tells you that you're going to get X amount of things for X amount of dollars, like a 1-to-1 ratio. It's not this like spectrum. Like it doesn't work. Like if you have $5, you can buy an infinite amount of things underneath that. That's not how, because things cost an exact amount. Other than shopping, like I guess in a common sense way, since we're told that voltage is going to be 12 volts or 5 volts or whatever, I guess it would be a fair assumption without further knowledge to say, well, if that's an exact output, then why wouldn't the current be? And I think that's not necessarily bad thinking initially, because a lot of things in the real world are an exact 1-to-1 kind of thing. Hardly anything operates off the idea of you'll get a maximum up to. Some things actually do run off that. Like, what's a good example of shady companies that say, oh yeah, like up to 5 gigabytes of storage or whatever. Well, that could literally mean anything below that. That's where it gets a little shady. But I mean, like other normal things you don't think of in terms of up to. In this case, it up to 2 amps is important information. It's not shady. So I just wish things were explained like that. So anyway, let me know if that kind of confused you in class, especially with going from the circuit schematic realm of everything being a drawing to the physical realm with actual parts, resistors, capacitors, inductors, integrated circuits, real power supplies from the lab, and then all of a sudden realizing that there's far more supplies than you ever thought possible. So, yeah, just something to think about. Like, comment, subscribe, and see you in the next one.